If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So in this lecture again we will be solving 5 questions starting from question number 56 to question number 60. Okay, then let's try to solve these 5 questions. Okay, in question number 56, the two transformers of same type using same grade of iron and conductor materials are designed to work at the same flux and current densities, but the linear dimensions is of one are 2 times those of the other in all respects. Linear dimension means length, breadth, height, all these dimensions, length and breadth. The ratios of kVA of the two transformers closely equals to. So in kVA you need voltage and current, both are multiplied because the dimension is, all the dimensions is 2 types. So your current densities and voltage flux densities are equal. They have same grade of iron conductor material, same flux and current densities. So current densities are equal because you have increased your area. So your total current is current density multiplied by area. So current density is equal, but your area will increase 4 times because each dimension is increased, length is increased 2 times, breadth is also increased 2 times. So area will get increased by 2 into 2, 4 times. So your current will increase 4 times. So I will increase by 4 times. Similarly your E is directly proportional to 4.4 for that phi A, that is core flux density into AB, 4.44 directly proportional to phi, which is phi is equal to AB. B is the flux density, A is the area. Again, because area is increased, so your total flux phi will increase. So therefore EU is also increased. Because it is increased 4 phi, that E will also increase by 4 times. So voltage is also increasing 4 times, current is also increasing 4 times. So your kVA will increase by 4 into 4, approximately equal to 16 times. So that is your answer. That is option A. Now if you come to in question number 57, what is asked here? Two transformers of different kVA ratings working in parallel, they share the load in proportional to their kVA rating, to their ratings, that is kVA rating, when there. So to share the power in there with respect to their kVA rating, that their impedance on per unit basis on their respective ratings are equal. That is what is required is that suppose you want to share it in suppose it is 10 kVA into 5 kVA, one transformer is 10 kVA, one transformer is 5 kVA. So you want to share the load as per 10 is to 5 as per their specification, 10 as per their kVA rating. So it should take 2 times more than this one load. Okay, because you want to make it in this way, so your impedance in this base and impedance in this base, that should be equal, that is per kVA impedance should be equal. So if it is a 10 ohm, suppose 10 unit, I am not writing on anything of 10 unit impedance, hypothetically I am just saying. So here also it should be how much then? 10 in 10. So per kVA it is 1, so in 5 it should be 5. So if you take per unit, here it is 10 by 10, 1. Here it is per unit also 1. So per unit value on their respective base. Here base is 10, here base is 5. On their respective base it should be equal. It should be per kVA basis. Per kVA basis how much impedance is there, that much per kVA basis impedance should be there. Then only it will be, or loads will be shared in the ratio of their kVA. So per kVA it should be same. So accordingly it will take. So per kVA means on their respective ratings. If you are dividing it by its rating, that means you are taking per unit with respect to this rating. You are dividing this one by its rating. That means here per unit is with respect to its rating. So it is per unit impedance that should be equal, but that per unit should be on their respective ratings. So that's why it is option B. Now if you come to question number 58, a Bucos relay is used for. I think we have explained this one in the protection of transformer. In the protection topic, we have completed that entire transformer protection. There it is already mentioned, Bucos relay is for the all internal faults. It are all interturn faults, incipients fault, winding to winding fault, winding to core faults, where there may be a chance of a gas maybe heating up, and then that oil gets heated and gases forms in the oil which passes in that path, which while going to out conservator, it strikes that Bucos relay in the path. So that's we have explained this one Bucos relay in details in the protection. I will give a link, you can check that link. So it is 858A. Now if you come to question number 59, a 50 Hz 220 by 240 kVA single phase transformer operates on 220 volt 40 Hz supply with the secondary winding. Then Okay, so what it is giving, it is reducing its supply voltage to 40 hertz. Rest is okay. So then what will happen? Because it is 220, you are applying 220 voltage, but it is 40 hertz supply. Okay, so if it is a 40 hertz supply, you have seen your hysteresis loss is directly proportional to b to the power 1.6 and f. Whereas your ED current loss, I have explained you, ED it was directly proportional to b square f square. Now B is directly proportional to, in case of transformer, B is proportional to this one V by F, because your E is equal to 4.445, instead of 5 you can write AB, and then so it is directly proportional to AB, F, everything. So your B is directly proportional to E by F, or we say it is V by F. So instead of this we write it V by F. So hysteresis loss is proportional to B to the power 1.6 divided by F to the power 1.6. Then this, if you divide F, so it will be 0.6, and your ED current loss is directly proportional to B square by F square multiplied by F square, that is V square. So because you have reduced F from 50 Hz to, you are now giving 40 Hz. From it was 50 Hz, but you are applying 40 Hz. So because you have reduced this one, so your hysteresis loss will get increased, but it doesn't get affected with frequency, because frequency it is proportional to V square. So it will remain same. That means ED current will remain same. It will remain same, but hysteresis loss will increase. This will increase. So that is, you can see your option C. ED current loss remains same and hysteresis loss increases. Now if you come to question number 60, two transformers of ideal voltages but of different capacities are operating in parallel for satisfactory load sharing. So this one you have seen, per unit impedance on their respective bases, that should be equal, not impedance only, per unit impedance. Okay, that is okay, they will share. If I say only per unit impedance on their respective bases are equal, capacities are different, so on their respective bases it should be, so on their respective bases equal. If you do this one, then they will share it in their respective kVA. But if your X by R ratio are not equal, then their power factor will be different. If it is equal, then their power factors will also be equal. Their power factor will also be equal. If your X is more, then obviously that transformer power factor will be lesser than the other power factor. So proper sharing, we will take care of that power factor, and also kVA it should share in their kVA rating. So both should be there. If I say only satisfactory load sharing, so if you do only per unit impedance, it will share the loads in their respective kVA ratio. That is question number 57 likewise. But along with this, if you do X by R ratio, then your power factor will also be equal. PFs will be also equal in both this transformer. So that's why the proper answer will be C. If you like the video, then press the like button and please give your valuable comments in the comment section.